Before we start showing you examples about how to use the quadratic formula, we're going to want to practice how to simplify expressions that have radicals within a fraction. So, for example, look at number 1 here. And we've got negative 9 plus square root of 180 all over 3. So the first step will be, of course, that we want to simplify the square root of 180. So square root of 180, we know that's 9 times 20. And 20 is 4 times 5. We're looking for perfect square factors. And so we've got square root of 9, square root of 4, and square root of 5. So take the square root of all these. So this is, a square root of 9 is 3. Square root of 4 is 2. And these two get multiplied. And then the square root of 5 is the leftover. So none of this is new. It's a nice review. So we've got that instead of the square root of 180, we're going to replace that with 6 square root of 5 all over 3. Okay, but we're not done yet. So now we're going to look at the numerator, and there are two terms, as you know, and there's a common factor. There's a GCF of 3. So we're going to factor out the 3. So it's 3 times negative 3 plus 2 square root of 5. And then, of course, this is over 3. And now you can see why we wanted to factor out that GCF, because now we can reduce the 3 here and here, 1 and 1. Okay? So the final answer is negative 3 plus 2 square root of 5. Okay, number 2, we have another fraction that has a square root, has a radical. Okay, we want to simplify. So square root of 128, that is 2 times 64. 64 is a perfect square, so we're going to take square root of 164, which is 8, and then this extra square root of 2 is there. So we're going to rewrite this as 20 minus 8 square root of 2 all over 8, just like that. Okay, and again, we have two terms in the numerator. Now notice what I'm not going to do. I'm not going to try to reduce this 8 with that 8. Why? Because we have terms up here, not factors, right? These are terms, not factors. And we can only reduce factors. So that's why instead of trying to do any kind of reducing here with these 8s, I'm going to look at the numerator and I'm going to look for a GCF. And the GCF is 4, right? So we're going to factor out a 4, which will give us 5 minus 2 square root of 2. And then we've got the 8 in the denominator. And now we're okay to reduce the 4, goes into itself once, and into 8 twice. Okay? And our final answer is 5 minus 2 square root of 2 all over 2. This is our simplified answer. Notice again, I am not going to do anything with these 2's because these are terms, not factors. So you are done. And when we go to solve quadratic equations with quadratic formula, we're going to end up with answers that look like our original problem, you know, our original expression up here in both of these cases. And so we are going to want to simplify as much as we can, simplify the radicands to pull out any perfect squares, factors, and then look for GCFs in the numerator that we can reduce with the denominator to reduce the fraction down to lowest terms.